In this video, we're going to talk about molarity versus molality. We'll start with molarity because that's a term that we should be familiar with. Molarity is equal to the moles of solute, which is the minority component, over the liters of solution. So if we're thinking about, for example, an aqueous sodium chloride solution, my solute would be the sodium chloride, my solvent would be the water, and my solution would be the combination of sodium chloride plus water. So if I wanted to make a 1 molar solution of sodium chloride, and let's make this aqueous, so we'll use water as our solvent, I would need to dissolve 1 mole of sodium chloride which is equal to 58.44 grams. So just using the periodic table to determine the molar mass, I could mass out 58.44 grams of my sodium chloride, and I would dissolve that in a total of 1 liter of solution. So this is where we use those volumetric flasks that are good for precise measurements. So what I would do is I would take my sodium chloride, put it into the volumetric flask, put some water in there to dissolve the sodium chloride, and then dilute with water exactly to that line. And so if I had 58.44 grams of sodium chloride in that flask, and I had a total solution of 1 liter as indicated by the volumetric line, then I would have exactly a 1 molar solution of sodium chloride. So molarity has a volume component, and volume is temperature dependent. If my temperature increases, then my volume also increases. And what that means is that molarity changes with temperature. So remember that molarity, big M, is moles of solute over liters of solution. If I'm going to be doing some work where temperature is going to be variable, then I can use another form of concentration called molality that is not temperature dependent. So molality is equal to moles of solute over kilograms of solvent. So because there's no volume component, this is independent of temperature. So a 1 molal solution, and this is with this little m, of sodium chloride is equal to 1 mole of sodium chloride over 1 kilogram of H2O. And we want to be able to convert back and forth from molarity, big M, to molality, little m. So let's say that we have a 0.5 molar solution of NaCl aqueous, okay? And we want to know what is the molality of that solution. So first we got to think about what that means. We have 0.5 moles of NaCl per 1 liter of solution. So our top part is fine. We're still going to be looking for moles of NaCl, but the bottom part is the solution. So the solution is my solute plus my solvent, and I have a volume here, and I want to be going from a volume to a mass. So what I'm going to need to do is figure out how many grams of that solution are solute and how many grams of that solution are solvent. So to do that, we're going to need a density. And let's say that the density of this solution is 1.05 grams per milliliter. So that's information that you would have to be given to solve one of these problems. So let's start with the solute. We have 0.5 moles of NaCl, and in every 1 mole of NaCl there are 58.44 grams. So that tells me then that I have 29.22 grams of NaCl. And this is my solute. So ultimately I'm trying to figure out how many kilograms of solvent I have. Okay, so I know how much solute I have now. I also know that I have 1 liter of solution, or I can assume that I have 1 liter if I'm using 0.5 molar solution. That's equal to 1,000 milliliters of solution. And from before, we know that for every 1 milliliter of solution, there's 1.05 grams of solution. So I have a total of 1050 grams of solution. So now I can take my grams of solution and subtract from that my grams of solute, and that gives me my grams of solvent, which is my H2O. So 1020.78 grams. There are 1,000 grams in 1 kilogram, so I have 1.021 kilograms of solvent. So my molality is equal to 0.5 moles of NaCl solute over 1.021 kilograms of solvent, which in this case is H2O, and that is equal to 0.489 molal. So I have a 0.5 molar solution and a 0.489 molal solution. I use density to convert from volume to grams, which allowed me to determine my bottom component here to figure out the kilograms of solvent. So I used the density to figure out how much solvent I had in the beginning. I used the moles and the molar mass to figure out the grams of my solute, and the difference between those is the amount of solvent that I have in grams. I convert to kilograms. Molality is defined as the moles of solute over the kilograms of solvent. So let's say that I want to prepare a solution. So I want to prepare a 2.12 molal, little m, NaCl aqueous solution, and I want to use 25 grams of H2O as my solvent. Okay, so what I need to know is how much sodium chloride should I put in there. So I know my molality. I don't know how much solute I need, so X moles of solute over 0.025 kilograms of solvent, which is my H2O. So I can set up this proportionality and solve for X. X is equal to 0.053 moles of sodium chloride. So then all I have to do is take that to grams, and I can do that using the molar mass. So if I have that many moles of sodium chloride, again, I know that in 1 mole there are 58.44 grams, and that is equal to 3.097 grams of NaCl. So to make the solution, I would mass out 3.097 grams of NaCl, and I would dissolve that in 25 grams of H2O. So for some practice before you take the reading quiz, you can do the conversion. What is the molarity of the solution I just made, which was 2.12 molal? So remember, this was a aqueous sodium chloride solution, and the key for this is posted on Moodle. So to finish up this section, you can read in Chapter 12 in your book about molarity and molality units, and then you can take the reading quiz. The reading quiz is due Monday.